What's up guys, welcome back to the channel. Today on this video we'll be finding the integral of this function here. As you can see, this function consists of 1 2 3 4 terms. Now each term you must be able to integrate it separately, but before we do that, you can pause this video and try to find the answer, and let's see if we're gonna get the answer as the one that we got at the end of this video. Just in case guys, you haven't subscribed to the channel, subscribe to the channel, hit the bell notification so whenever I upload you will able to see the new video. If you want to watch the whole videos that I've done already on different chapters, you can go to the playlist section of this channel and watch those chapters. Alright guys, let's start. So here's what you need to know. This function here, all these terms in fact except for one, they need to be simplified. So we need to simplify this function here. Remember, when we simplify, the sigma and dx, they still remain there. Alright, so let's simplify. So let's look at our first term. Our first term is 1 over cosec. As you know, 1 over cosec is an inverse of, is it, oh, sine, yes, almost forgot it there. It's an inverse of sine minus 1 over sec. It's an inverse of cos. There we go. Right, if I can slightly forget them, it means you can also forget them. So basically what I'm trying to tell you is be very careful guys when you solve these problems. So these are inverses. Just in case you don't know much about inverses or reciprocals, I made a video here showing all the inverses that are available on these trigonometric functions. Alright, now let's continue. What about this one here? So this one is, if you look at the numerator there, we have sine 2x. This numerator here, this is a double angle identity for sine. So the double angle identity is gonna give us 2 sine x multiplied by cos x. Don't forget this is divided by this cos here, cos x plus 1. So this one is just 1. Right, let's go back here. Some of you might not understand why we change this. This is a double angle identity for sine. Again, if you want to learn more about it, there's a video there that will pop up. Go and watch those double angle identities. Right, now when we have this, now it's time for us to do the last part. We say cos divided by cos x is going to give you 1, so you're going to be left with 2 sine x. So let's rewrite this. Sigma, now we have sine x minus cos x. Remember, we left with 2 sine x plus 1. Then this dx, remember we are integrating in respect with x, that's why we have dx there. And from here we can start integrating. Why? Now what is the integral of sine? So sine, if you say sigma sine n, which is a coefficient of x, the integral of sine is going to be negative cos n x over n plus c. Don't forget that guys, I made a video about these integrals here. I'm gonna show you the video after here. Right, so when we find the integral of this, it's gonna give us negative. So we have negative cos x, but then our n is 1, so even if you divide by 1 here, this is still like that. We are fine. What about the integral of cos? So the integral of cos, gotta write it here guys, just a reminder. This is just a reminder, right? y is equaling to, this time around, it's positive. Remember, integration is the opposite of differentiation. Do not mix the two, because that's where most people they get confused here, right? So positive cos, it's gonna give you the positive integral of sine, right, plus c. Don't forget this plus c, it means indefinite integral and also constant, right? So c means it's a constant. So we don't write it here when you substitute, guys. We write at the end of everything here. So since this is negative here, we want to have, remember this is positive, so we want to have sine x. Our n is 1 divided by n, so that is going to be negative sine x. Remember this negative is from the equation there. Now what about this one here? Now we're going to use this one because we are integrating sine. It's just that here we have a coefficient, but then what is going to be our answer here? You can say plus 2 is our coefficient, and then from there negative cos x, right? Remember guys, remember this, and the coefficient of x is 1, so you divide by 1 here, so it's gonna give you that. So just in case guys you want to learn more about trigonometric integrals, go to this video here. I explain each trigonometric ratio that we can integrate. Alright, now let's continue. Now we have a constant here. Remember, when we integrate the constant, we just multiply that constant with the variable that we are integrating with respect with. In this case, the variable is x, so this is going to be x. 1 multiplied by x, and it's x, plus c. As you can see, the c, the constant, we'll write it at the end. Please don't differentiate one term then write plus c. No, you don't do that, guys, right? You differentiate all of them separately, but then all of them, they're gonna be added by c at the end, right? So from here we just simplify. So let's do it. So as you can see here, we have negative cos, and we also have 2 negative cos there. So these 2 negative cos here, they're gonna give us 3 negative cos x, right? And then we also left with sine, negative sine here, x, right, plus x plus c. So this is how you do this problem here, guys. Okay, this is how you do this problem here. Just in case you're confused, you can rewatch this video over again. If it so happens that it doesn't help you, you can comment on the comment section. And if you haven't subscribed to the channel, subscribe to the channel, click the bell notification, and also do not forget to share this video to your friends. Alright guys, at the end of this video, there is a playlist where I differentiate functions similar to this one. If you want to understand better, go and watch those videos. Just click on that playlist that appears on the screen. I put them in a sequence order. Thank you very much guys for watching. Till next time, cheers.